Welcome to the Explainer. Today, we're jumping into Docker. It's the tool that tackled one of the most frustrating problems in software, and honestly, it has completely reshaped our digital world. Once you get it, you'll start seeing its impact absolutely everywhere.
All right, so here's our game plan for this explainer. We're going to start with a classic developer headache, then introduce the really elegant solution. After that, we'll break down the key ideas that make it all tick, see how it works in the real world, and wrap up with why this is such a huge deal.
So, let's set the stage. We're going to start with a super common, and I mean super frustrating problem in the software world. It's a phrase that has probably caused more sleepless nights for engineers than any other.
I'm sure you've heard this before, right? A developer says, but it works on my machine. It's this universal cry of despair. Code that runs perfectly on their laptop just completely falls apart on a testing server, or worse, when it goes live for users. And all this chaos, it comes from these tiny, invisible differences. Different software versions, different system libraries, maybe even a different operating system. And this is the heart of it, you know? It's the environment dilemma. You have these inconsistent environments that lead to totally unpredictable results, wasted hours, and delayed projects. So the big question becomes, how do we get software to run reliably, everywhere, every single time? And that question brings us to our solution. This is where Docker enters the story. It was designed to solve this exact problem by changing the whole game of how we package and ship software. So, what is Docker really? At its heart, its whole purpose is to package up an application with all its dependencies. We're talking the code, the libraries, the config files, literally everything it needs, and put it all into a single, standardized unit. The best analogy? It's like a shipping container for software. And this slide just lays out the shift perfectly. You go from this chaotic, error-prone process that's full of guesswork to something streamlined and reliable. With Docker, your code just runs the same everywhere. From your laptop to the production server, the environment is completely identical. So how does Docker pull off this magic trick? Well, it's not actually magic. It's a set of really clever building blocks. Let's break down the 6 core concepts you gotta know to really wrap your head around containerization. First up, we have the Dockerfile. Just think of this as a recipe. Seriously, it's just a plain text file that lists, step by step, every instruction needed to build your application's environment. Things like, okay, start with Ubuntu, then install Python, now copy my code into it, and finally, here's the command to run when you start up. Now, when you follow that recipe, what you get is a Docker image. This isn't the running app itself, okay? It's more like the final packaged product. Think of it like a perfectly assembled piece of IKEA furniture. All the parts are there, it's ready to go. It's a read-only template, a snapshot, frozen in time. And when you actually run that image, that's when you get a container. This is the main event. This is your live running application. And the most important part is that every container is completely isolated. It's like its own tiny, self-contained computer. You can run dozens of them on the same machine, and they have no idea the others even exist. So, you've built this amazing portable image. Where do you put it? In a Docker registry. Think of it like GitHub or an app store, but for Docker images. You can push your own images up for your team to use, or you can pull down official pre-built images for stuff like databases or web servers. The biggest public one is called Docker Hub. But wait a second. If containers are just temporary, what happens to important data, like all the user info in your database? Well, that's where Docker volumes come in. They are absolutely essential. A volume is basically an external hard drive for your container. It connects a folder from your actual computer into the container, making sure your data stays safe and sound even if the container gets deleted. And finally, let's be real. Most apps today aren't just one thing. They're a bunch of different services working together, a website, a database, an API. Docker Compose is like the conductor for this whole orchestra. It lets you define your entire application in one single file, so you can start, stop, and connect all the different pieces with just one simple command. Okay, so now we know all the individual parts. Let's see how they actually fit together. We're going to look at one of the most common and powerful Docker commands out there. See, it all comes together with this one simple command, Docker run. This one line kicks off the whole process. It tells Docker to find the right image and instantly launch your entire application inside a new, perfectly isolated container. And this slide shows you exactly what's happening under the hood when you do that. So you type Docker run,
First, Docker grabs the image it needs from a registry. Then it creates a brand new container, gives it a file system, sets up all the networking, and boom, it starts your application. It's like going from a blueprint to a fully working house in seconds. It's incredible.
So we've covered the what and the how, but let's finish up with the most important part, the why. Why did this technology have such a massive, revolutionary impact on pretty much the entire software industry?
Well, when you boil it all down, Docker is the ultimate answer to that "it works on my machine" problem. It guarantees consistency everywhere. It creates true portability, so your apps can run anywhere. It makes deployment so much simpler, and maybe most importantly, it lets developers build and ship software faster and with way more confidence than they ever could before.
So that's Docker for you. It's a foundational piece of modern cloud computing that's powering everything from tiny startups to the biggest companies in the world. And as software keeps getting more and more complex, it really makes you wonder, right? How is containerization going to keep shaping its future?